Hello everyone and welcome to another Plaxis 2D tutorial. In this tutorial I'll be showing you how to use Plaxis 2D to do flow analysis for an embankment. So let's get started. So for this video I have already opened chapter 10 over here of the Plaxis 2D tutorial. And the title is Flow Through an Embankment. And the main material of this embankment would be sand. So it's just a granular material. And the main objectives over here for this chapter is to perform flow-only analysis and using cross-section curves. And this is a screenshot of the geometry of the project or the geometry of the finite element model. So if we scroll down, it says that we must use a plane strain model with 15 noded elements here. So I'll just quickly name this as flow through embankment tutorial. And I'll move straight to the model tab here, and we can see that we're using the plane strain model here with 15 noded elements here. So now let's look at the model dimensions. So it says x minimum is at 0.0 meters and x maximum is set to 23.0 meters here. So I'll key in 0 here and I'll key in 23. And for y minimum values it's set to 0.0 meters and the y maximum value is set to 6.0 meters here. So we already have 0.0 here for y minimum, and I just need to key in 6 for y maximum here. And moving on to the constants tab, I just need to change the unit weight of water to 9.81. Even though it's not mentioned, it's best practice to just use 9.81. And there's nothing to change for the cloud services tab, so just click on OK. And now we need to define the embankment over here. So we can refer to this table here, which contains the X locations for the boreholes over here. We have 4 of them. And we must make sure to key in the correct head levels over here, or else we can have a wrong graph in the end. So now let us focus on the placement of boreholes. So back to Plaxis 2D, I will use the create borehole tool over here. And it says that we should place one at 2, 8, 10, and 20. So I will find 2, 0. So one over here. And then I will add another one at 8. So for those of you who are not familiar with using this borehole button, you can actually add additional boreholes here just by using this add function here, and you can key in the X coordinate. So it's a lot simpler than trying to locate the point on the screen. And the next one is at 10 meters here. And the next one is at 20. So now we can see all 4 of the boreholes here, as you can see. And we only need one soil layer, as you can see in this screenshot here. So I'll just click on add once, and now I will key in the tops and bottoms for each of these boreholes over here. So for borehole 1, the top is set to 3 meters here, so I'll key in 3, and the bottom is at 0. And for borehole 2, we are setting the top to 6 meters, and this value is the same for borehole 3 as well. So I'll key in 6 here and 6 here. And finally for borehole 4, the top is set to 1 meter here. So I'll key in 1. And that's it. Now we just need to define the heads now. So over here for borehole 1, we can see the X value for borehole 1 and the head. The X value is set correctly at 2 meters here, as you can see. And the head value for borehole 1 should be 4.5 meters. And this value should also be the same for borehole 2. So I'll key in 4.5 here and 4.5 here. And for borehole 3, the head is slightly lower at 4.0. So I'll key in 4. And finally for borehole 4, the head is set to 1 meter here. So I'll key in 1. And that's it for the geometry for this model here. Now we just need to focus on the material of this model. So now we will define the sand material. In this case, we'll be using a linear elastic model. So we will change the material model to linear elastic. And since we are dealing with granular material, so we'll use a drainage type over here. As you can see over here, it's set to drain. So unsaturated and saturated unit weights are set to 20 kilonewton per cubic meter. So key in 20 in these two inputs here. And we don't have to key in anything for the initial void ratio here. So we can just move on to the parameters tab. And the Young's modulus value is set to 10,000 kilopascals here, and the Poisson's ratio is set to 0.3. So key in 10,000 here, and key in 0.3. Now we can proceed to the groundwater tab here. We can see that we are supposed to use a standard data set. So we already have a standard data set chosen here. And the soil type should be selected as medium fine. So change it to medium fine. And for the flow parameters here, we need to change it from none over here to from dataset. So click on the drop down and we can find from dataset over here. And we can ignore the interfaces and initial tab sheets because they are not relevant here. So we can just click on OK and OK once more. And we can assign the material here and click on OK. And this is our model geometry here, so it's very similar to the screenshot over here as shown. So now we can proceed to the meshing tab. So just go to the mesh tab here and click on generate mesh and click on OK once we have chosen the medium element distribution setting. And to know whether or not we have already generated our mesh, we just need to read this command line here. If it says mesh generated 129 elements and 1127 nodes, that means the meshing is already done. So now we can scroll down and now we need to define the calculation phases. So we can proceed to the flow conditions tab here, and this is where things get very important over here. So in the initial phase, the groundwater flow is in a steady state. And if we look over here, we must use a flow only option as the calculation type. So double click on this phase here and change it from K0 procedure to flow only. And automatically we'll be using a steady state groundwater flow. And as you can see over here, once we've already chosen a flow only option, we can already just click on OK. Now all we need to do is just expand the Model Explorer Model Condition subtree. So the Model Explorer is over here. So everything concerning your model will be over here. So click on the plus button over here for model conditions over here. And click on the plus button for groundwater flow. And as you can see, we are supposed to have a bottom boundary that's closed. So we've already ensured that the bottom boundary is closed by ensuring that boundary Y minimum is set to close over here. Now we need to move on to the sixth step. And you can see that the Model Explorer also contains the groundwater flow boundary condition subtree. So you can find this by clicking on this plus button here. You can find the groundwater flow base boundary conditions here, and there are quite a few sections over here. So now moving on to phase 1, we need to use a transient groundwater flow. So I'll quickly add a phase here, double click on phase 1, and I'll change it from steady state groundwater flow to transient groundwater flow. So this means that the flow will vary with time, and the time interval is set to 1 day over here. And the numerical control parameter subtree is set to a maximum number of steps stored of 50. So key in 50 here, and then click on OK. That's about it. And now we need to use the select multiple objects button, and we need to find the select water boundaries tool. So just click on the drop down for select multiple objects and find select lines, and under select lines you can find select water boundaries here. If you don't see a cursor, you can hit escape twice and try again. Hopefully it'll work, but sometimes Plaxis 2D is a bit buggy. If it doesn't show up, then just leave it as it is and just try to do your best with selection. So one thing to note about this screenshot is that we're not supposed to select the base. We're only supposed to select this face, and this face only. No other faces are required. So just select like this, and there we go. And it says that we need to right click and activate. So right click and click on activate here. And in the selection explorer, set the behavior parameter to head. So we'll change this to head, and we'll keep it at uniform over here. And the reference head would be 4.5 meters. And time dependency wouldn't be constant. In this case, it would be set to time dependent. So I will choose time dependent here. And for the head function, I'll just click on the plus button here, and I'll key in 1 meter for the amplitude, 0 degrees for the phase, and 1 for the day. So 1 meter for amplitude, 0 for phase degrees, and 1 day. Click on OK. And the settings over here will be shown. So if I were to go and change this to 10 days, for example, and if I want to see the settings of head function 1, you can see that it will change if you change the values there. So that's one way of changing things. So I'll assign head function 1 back to phase 1, and I'll check on the settings and they're correct. Now let's move on to phase 2. The only difference is that the period is set to 10 days. So for head function of phase 2, I'll just create a new one. The amplitude is the same, the phase is the same, but the period is different. So it'll be a period of 10 days. So click on OK. And as you can see, phase 2 has a period of 10 days and phase 1 has a period of only 1 day. The rest will be the same. So now that we've already dealt with most of the settings for the selection explorer, we need to double check the second phase over here. We need to make sure that the maximum number of steps stored is set to 50, and the time interval is set to 10 days, and it's correct that we're using transient groundwater flow here. So click on OK. So that's about it for the flow conditions. So now we need to just select points for curves over here. Click on I agree and continue. So it says that we must use the point 0, 3 and 8, 2.5. So type up 0 and type up 3 here. Search closest. And this is where Plaxis 2D's UI isn't that good. you need to drag this up here, then you can find it here. So we have a node that's exactly 0, free, and we've already selected it here. Now we need to go and drag this back down and then key in the value 8, 2.5. So key in 8 here and key in 2.5. Search closest. And we need to drag this up again. And this is the closest point to 8, 2.5. So that will do. Click on update to close the output tab for now. Now we need to go and calculate things. It shouldn't take long. And there we go. So now we can view the results. Click on I agree and continue. And here is the output tab right now. We can quickly deal with the graphs first before we deal with the animations. So it says that we should use the cross-section button here and then key in these points. So let's do that. So use this line cross-section tool on the left here and then key in the values 2, 3 and 20, 1 and click on OK. And now move to stresses here. Go to pore pressures and click on P active. So we've already done this second step over here. Now we need to proceed to the cross-section curves option in the tools menu. So just click on this button over here. And it says that we can view the first phase by selecting this box here and changing the selection style to individual steps. There we go, and click on OK. It will take a short while. Oh, it's faster than I thought. So this is the graph over here. So you can see this pattern, which is the same as the one over here. Although we have slightly less points than the graph over here, but in general we have the same shape. The minimum and maximum values will be fairly similar, as you can see. Now we can proceed to preparing the first phase. So we can go back to window and go back to the second window over here. Go to the cross-section curves and select the final phase and choose individual steps and click on OK. And here is the second graph over here for phase 2. As you can see, it has the correct shape and the p-active value ranges are very similar, as you can see. So now let us focus on creating our animation. So go back to the window drop down and click on number 1. And now to create our animation, we just need to go to File and click on Create Animation. And I'll just use an image width of 1920 and image height of 1080, since this is the resolution of my screen. And for the animation speed, if you look at the screenshot over here, it says that it's using an animation speed of 100 FPS. This is a very nonsensical setting because if you only have a couple of frames, this video would last less than a second. So this is not required whatsoever. We can just keep it at 1 frame per second. And the other settings here, like show legend and use current legend or scale factor, is fine. And it is said that we should do an animation for phase 1. So just uncheck the other 2 phases over here and make sure that phase 1 is checked over here. And I'll quickly set up the location of my video. And click on OK once you've already chosen the correct location for your animation, and I've already titled it accordingly. So this is a 45-second animation, and we can clearly see all of the individual steps nicely in a timely manner. This is because of the 1 frame per second frame rate. So since we are using a frame rate of 1 frame per second and we have 45 seconds here, so in total this animation has 45 frames. So you can imagine if you're playing at 100 frames per second, it's about half a second for this whole animation, so you can barely pause the video and notice what is going on. And that's it for this video today, folks. I hope you found it useful, and I hope that you learned something new about Plaxis 2D. If you want to watch more Revit tutorials or Plaxis 2D tutorials, do consider subscribing to my channel. It's free. And as always, I hope that you're safe in these unprecedented times. Take care, keep learning, and goodbye.